sure you can get these two types of problems down packed. You only have 4 word problems for your homework, which is these 4 right here. And the rest are just equations when we get back to the normal solving. So, here's our first one. We went through all these yesterday. All right, we got a riverboat. Now, we've seen these types of problems before, so let's bring them back into our memories. I don't know if it was back in chapter 7. So we got a boat for tourists, and it's averaging 12 miles per hour in still water. It takes the boat an hour and 4 minutes to go 6 miles upstream and return. Find the speed of the current. All right. So, what do we got going on here? We've got a boat. There's my boat. My boat's going upstream. I feel like that should be downstream, though, huh? All right, so we'll call that downstream. Downstream. And then we've got our boat going back upstream. So, for both of them, I want to be thinking about distance equals rate times time. Do we know the distance for both of them?
6 miles. 3 miles.
2 miles each.
12 miles.
To go 6 miles upstream and then return. So it's going 6 miles down, 6 miles up, right? So for both of them, my D is going to become 6. So far, so good. Yeah? All right. It takes the boat 1 hour and 4 minutes to go both ways. So I can't put in an hour and 4 minutes into both of them. I can't divide it by 2 because it's not going to be equal. There'll be a different time going down as it would going up, right? Because going upstream should take longer than going downstream. So now let's think about the rate, the speed. If the boat itself is traveling 12 miles per hour and it's going downstream, what's happening with the current and that 12 miles per hour? It's adding to it. So here, our rate is going to be 12 plus x. So this is the speed of the boat plus the current. Does that make sense? So if I plug in this expression for my rate in our distance equals rate times time, R becomes 12 plus x, and that stays a t. How do you solve this equation for t? Divide. So we end up getting 6 over 12 plus x equals t. So what does this 6 over 12 plus x really represent? What specific time? The time that the boat is going downstream, right? Okay, so let's do the same thing for upstream. What's going to be my rate for going upstream? Yeah, now be careful. It's going to be 12 minus x, right? So it's 12 minus x because it's my speed of the boat minus the current. So we're going to put that in for r. So 12 minus x and then t. Solving that equation for t would get us 6 over 12 minus x. So that means this expression equals the time for the boat to go upstream. These two times added together should equal what total time?
The distance go up and back.
The 1 hour and 4 minutes, right? Because they're telling us the total trip was 1 hour and 4 minutes. All right, I'm going to erase some stuff so I get myself some space. Does everybody have all that? Okay, so here's my equation. We want to write it out literally. It would be the time down plus the time up equals total time. So the time that we said for it to go downstream was 6 over 12 plus x, plus the time to go upstream, we said was 6 over 12 minus x equals, now here we have to do a little bit of thinking, 1 hour and 4 minutes. What does that look like as a fraction? These are in fractions, these are in fractions. I want to put that in a fraction. What fraction of an hour is 4 minutes? It would be 4 over 60, which reduces to 1 over 15. So 1 hour, 4 minutes would be 1 and 1/15 of an hour. Put that into an improper fraction. Yeah, so it'd be 16 over 15. So I'm going to equal this to 16 over 15. Can we solve that equation?
Yeah.
Hopefully you did it for your homework. What do I need for the first fraction that's not there? Good. 15 and 12 minus x. So times a 15 times a 12 minus x. Second equation, what do I need that's not there? 15 and a 12 plus x. Last one I need what? Yep, 12 plus x, 12 minus x. All right, so let's go ahead and solve that. 15 times 6, 30? I mean, not, it's 90, right? So it'd be 6 plus 3, 90? Yeah? What, I don't know what 90 times 12 is. Well, I can figure that out. 9 times 12 would be 108. So add a 0. So it'll be what? 108 with a 0, so 1080. 90 times negative x would be negative 90x. What am I going to get here? It's just going to be the same thing, but plus 90x, right? So plus 1080 plus 90x equals... Okay, so let's multiply these out first before I distribute the 16. What's going to happen to my middle two terms? They're going to cancel, so really I'm just going to have 144 minus x squared, or yeah, x squared. I have no idea what 16 times 144 is. 2,304. So I get 2,304 minus 16x squared. Okay. Let's combine like terms over here. What happens to my x terms? They're going to go away. That's nice. What is 10,080 plus 10,080? 60, right? Why would it be 1?
I threw an action over there.
Yeah, because it'd be 0 and 0, right? 2,304 minus 16x squared. Is my quadratic term positive right now? Nope. So let's move everything to the left side. So minus 2,304. Add your 16x squared over. So then we get 16x squared. What's that going to get me? Huh? Negative 144. And ooh, that's a difference of squares, isn't it?
Yeah.
Or we could solve it by the square roots. How do you want to do it?
So the square is so much easier.
So that would be what? 4x minus 12, 4x plus 12. Technically, if I was factoring it, I should have taken out the GCF first, but that's okay. We can find our zeros from that very easily. What are my zeros? 3 and negative 3. Now, which answer makes sense to this problem? Yeah, find the speed of the current. Well, it's not going to be negative 3 miles per hour. So 3 miles per hour.
I took up 3/4 of my page. No, yeah, seriously though, like, it really did take me 3/4 of my page. I'm gonna have a lot
There's no shortcut.
Can we just like, can we burn it? No solution?
No, you can't just write no solution.
Yeah, hey, it's okay, we can mend it again with the other device.
Okay? All right, so what I want you to do, I won't make you solve this. I just want you to set up the actual equation. See if you can just set the equation up without solving it. So it says in 1.75 hours, Kim rows her boat 5 miles upriver and comes back. Here, they're giving you the speed of the current and not the speed of the boat, so that's a little bit different than what we just did. We want to know how fast does Kim row. So we want to know what her speed of the boat is. So see if you can set it up. You getting that? Yes? No? So downstream, we're going a distance of 5. Our rate is the speed of Kim's boat plus the current, because she's going to be going faster, times time. So that means the time going downstream is the expression 5 over x plus 3. Going upstream, she's still traveling 5 miles, but now the speed of her boat's fighting against the current, so I'm going to slow it down by subtracting the 3 times time. Solving for t gets us the expression 5 over x minus 3. So that's the time it takes to go upstream. The total time, so adding the 2 times together, is equal to 1 hour and 75. So that's what 1 3/4. So 1 3/4 as an improper fraction is 7 over 4. And then we would just solve it like we would normally solve it. This would need what? A 4 and a x minus 3. Second fraction would need a 4 and an x plus 3. And then the 7 would need the x plus 3 and the x minus 3. Okay? So that's the first type of problem you're going to have to do. That's 33 and 35. Got it? Might be airplanes. They might throw it off a little bit and take you from the water to the air. You'll be okay.
I tried to draw an airplane on one of my quizzes sometimes, and I'm like, what is this?
All right, last type of word problem you're going to have to do. The work problems. Remember the ones it takes so-and-so this long to do a job, if they do the job together, all that fun stuff? Yeah. All right, so we got people, carpet layers, coming in. They want to carpet your room. Together it's going to take them 4 hours to lay the carpet down. If each worked alone, one of them could do the job in 1 hour less time than the other. How long would it take each carpet layer to complete the job alone? Okay, so the first thing we should ask ourselves is, what should X represent? Right, we're trying to figure out the time for each person to work alone, right?
Yes.
Okay, so now let's think about this. If, these are kind of harder because we can't just do a normal D equals RT and then plug stuff in. If we had one whole job being completed, okay, and it took 4 hours to do, worker 1 would be doing a fraction of that job, and worker 2 would be doing a fraction of that job. And together, add it together, it should equal one whole job. Does that make sense? Let me say it again. So worker 1 is doing a fraction of the whole job. Worker 2 is doing a fraction of the whole job. Together, they're creating one whole job. Yes? Is that in our brains? So I'm going to equal this whole thing to one whole job. Because together they should be able to do one whole job. Okay, so we are going to take the total time that it took them, which is 4, and make that the numerator of both workers. So if this represents worker 1, this represents worker 2. So in 4 hours, let's say worker 1 was able to do X amount of time. So he's the faster worker, or sorry, the slower worker. Worker 2 could do the job in 1 hour less time than the other. So what would that look like over here? Yeah, x minus 1. And that's going to be your equation. So you just put your time, your total time up top. And then down here you're kind of thinking about the speed, or however you want to talk about it, speed of the worker. Or one of them will always be x, and the other one will always be a comparison to x. So did they take longer? Did they take shorter? And then you're always, 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 always going to equal it to one job, unless they say they're doing 2 jobs, but I don't think that's going to be the case. All right, so how do we solve that? First fraction needs what? An x minus 1. Second fraction needs an x. The 1's going to need, both an x and an x minus 1, which is x squared minus x equals, what do we get on the left side? 4x minus 4 plus 4x. Combine like terms. 8x minus 4 equals x squared minus x. Where should we move everything? To the right. So subtract x, add 4. Subtract 8x, add 4. So 0 equals x squared minus 7x plus 4. Thank you. 9x plus 4. Is that factorable? Definitely not. Quadratic formula, or do you want to complete the square? Complete the square with an odd number? Why not? All right, you do quadratic formula, I'll complete the square and see if I don't make a mistake this time. So it'll be x squared minus 9x plus blank equals negative 4 plus blank. 9/2 squared is 81 over 4. 81 over 4. X minus 9/2 squared equals minus 4, 16. 81 minus 16. 7, 5, 65 fourths. Square root. So I would get x equals 9/2 plus or minus root 65 over 2. So any perfect squares come out of 65? I don't think so. Bless you. Nope. Look at that. Did you guys get that with the quadratic formula? Did you get the same thing?
Yeah.
There you go. There it be. All right, so let's try setting this one up together. We won't actually solve it. Did I erase that too soon? Oh, I didn't make it fancy and put set notation around that. All right, so let's see if we got this set up. 2 chefs preparing a banquet. One chef could prepare the banquet in 2 hours less time than the other. Together they complete the job in 5 hours. How long would it take the faster chef working? I think it's supposed to say alone, not along. So the whole thing's going to equal 1, because we're doing one whole job, one banquet. Bless you. Chef 1, give me their fraction.
0. We're trying to do this problem. Okay, then.
5 over 5 over x, sure. Plus chef 2, x minus 2. Done. Do we need to solve that?
Should I even write this problem down?
Up to you. I'll give you some time.
If I don't write them down, then I don't know what I'm doing.
All right, I think this is what we should do. So I want you guys